So here we have distance versus displacement, two terms which seem to be confusing. Okay, these two terms confuse students the most in the beginning of this chapter. This what is the difference between distance and displacement? I'm not going to give you the definition first, or it will be enough to confuse you. So I'm going to give you example first. I'm going to explain to you the meaning of this, and then I'm going to give you the definitions. Let's say I have 2 points A and B, which are located on two banks of a river. This is a river, and let's say the river has certain current which are not equal. Okay, and let's say I have to cross this river from A to B, right? So every time I try to swim over here, I will be deflected to some extent, and let's say I get a zigzag path somewhat like this thread. Okay, so I have laid this thread over here and I cross this river following this path the thread has followed. Okay, let's say due to unequal currents I start crossing from here, and I cross this path over here and I reach this point B. Let's say your brother is standing at this point, he's trapped, you have to go and rescue him, so you start from A and you reach B using this path. But don't you think that the shortest path will be this straight line? It is just that the current was there and you could not row so that you could follow this straight path, that you were deflected. But let's say you were on a lake, a still lake, and this is point A and this is point B. Okay, so now you could easily take a boat and follow this path, the shortest path. Okay, this path, the shortest path between the two endpoints, is known as the displacement. It is a vector quantity. Okay, and this path which I have followed, it is the distance. The path which has been followed by the string is a distance, and this is written by D, and it is not a vector, it is a scalar. Okay, this is a curved path, you can see, but the shortest path was the straight line. Okay, this straight line was the shortest path because we know from our basic mathematics that the shortest path between any 2 points is a straight line connecting them. So if this straight line is connecting these 2 points, then this straight line must be the shortest path between them, and this straight line is referred to as the displacement. Whereas the path that the string followed, somewhat that path was the distance. Okay, so let's say I have to move from this point to this point, A to B, and I follow this zigzag path. Okay, let's say a drunkard is moving from the point A to point B, from bar A to bar B, and he follows this zigzag path. Okay, but on the other hand, a policeman, let's say, who is there to catch the drunkard, he starts from bar A and he moves directly to bar B, and he will reach in the short time if the speed of the drunkard and the speed of the policeman. I will come to the definition of speed, but you know, you have an intuitive definition from mathematics classes what is speed. If the speed of the policeman is greater than the speed of the drunkard, then the policeman will reach bar B earlier and he can wait over there for the drunkard to arrive. The drunkard has traveled a distance. This is the drunkard's distance, while the policeman, the policeman has taken the shortest path from A to B, which is known as the displacement. Okay, the policeman has covered a distance which is equal to the displacement from A to B, while the drunkard had also a displacement from A to B, but he took yet another path and had a distance and had to cover a distance. Okay, so that's what is the thing. It will get more clearer as we do more examples. Okay, so let me tell you the real definition of distance and displacement. Now you will see that distance is the actual path length between 2 points and displacement is the shortest path length between 2 points. So now if the drunkard follows this path somehow, let's say the drunkard is able to is not so much drunk that he would kind of forget his path, but let's say the drunkard follows this path and the policeman also follows this path. So both of them will cover a distance which is equal to the displacement from point A to point B. Okay, so the magnitude of distance is always greater than or equal to the magnitude of displacement. Okay, So the magnitude of distance is always greater than or equal to the magnitude of displacement. So this is the short, because displacement is the shortest path. So the length of the shortest path is always less than the length of any other path. At most, the length of any other path can be at least equal to the length of the shortest path, or the length of the length of the shortest path can be at most equal to the path which have been traversed by a body. Okay, so I think that settles with the difference between distance and displacement. So in the next class we are going to talk first about what is a scalar and what is a vector, and why is distance scalar, displacement vector, and then we are going to introduce what is velocity, what is acceleration, and after the next class we are going to study what are the equations of motion. So thank you.